Dear students, today we are going to study the Maxwell's fourth equation. As you have studied three equations of Maxwell, now we will study the fourth equation. Maxwell's fourth equation is based on Ampere's circuital law. You have studied this law in your class 12th. It states that the line integral of magnetic field over a closed path is equal to mu times the net current passing through the closed loop. Means if we have a closed loop and the current I is passing through the closed loop, you know that whenever a current flows in a closed circuit, there is a magnetic field produced around the closed loop. So the Ampere circuital law states that the integral of magnetic field, the line integral of magnetic field over a closed path is equal to mu times the net current passing through the closed loop. Means when the current passes through the closed loop, there is magnetic field generated around the closed loop. The line integral of that magnetic field that is produced due to the flow of the current is equal to mu times the total current passing through the closed loop. This is our equation number 12. We can write it in terms of current density. What is current density? Current density J. J is defined as summation of I divided by the area. So summation of I, the current will be equal to closed integral over the closed surface S J vector dot dA vector, where J is the current density. When we put this value into equation number 12, it comes out as B dot dr is equal to mu integration closed surface over the closed surface S J dot dA. We will apply the Stokes curl theorem here. As you know that the Stokes curl theorem relates the line integral to the area integral. So you can see integration over the closed loop C over the closed surface C B dot dr B vector dot dr vector is equals to integration over the closed surface curl of B dot dA, where this is the dot product. From equation number 13 and 14, you can see curl of B is equals to mu J, where J is the current density. This is the fourth equation of Maxwell. But this equation has some inconsistency in this equation. What is the inconsistency in this equation? We will go through it. If we take divergence on the both sides, यदि हम दोनों तरफ इसमें डाइवर्जेंस लेंगे तो क्या होगा? देखिए, डाइवर्जेंस ऑफ कर्ल ऑफ बी, divergence of curl of B is equals to mu divergence of J. As we know that divergence of a curl of a vector is always 0. Divergence of a curl of a vector is always 0. So the left hand side will always be 0. If left hand side is 0, we will be having divergence of J is equals to 0. We know that from the continuity equation, this is the continuity equation, this equation, divergence of J vector plus del rho by del T is equals to 0. What is rho here? Rho is the charge density. This equation is called the continuity equation. Divergence of J vector plus del rho by del T is equals to 0, where rho is the charge density. If we compare equation number 16 and 17, we see that Ampere's law is valid only for steady currents, means for which rho is equals to 0. जिसके लिए charge density 0 है या the variation in charge density is 0, then In this case, this is called the steady current. इस केस के लिए क्या होगा, जो एम्पियर्स लॉ होगा उसी के लिए वैलिड है जबकि आपका चार्ज डेंसिटी 0 है. It, but we should have an Ampere's law which is valid for steady and non-steady currents. So, how can we get the Ampere's law which is valid for steady and non-steady currents? This contradiction, it was removed by Maxwell by giving the following equation. ये जो contradiction था Maxwell ने किस तरह से remove किया, उसने he suggested that the current density J is equals to Jf plus Jd. What is Jf? It is the current density due to free charge. And what is Jd? It is the current density due to displacement current. Okay. So now we will put this value into equation number 15. We will put this value of Jf plus Jd into equation number 15. What is that equation number 15? The equation number 15 becomes the curl of B, curl of vector B is equals to mu Jf plus Jd. If we again take divergence on both sides, what do we get? Divergence of curl of B. Divergence of curl of B is equals to mu divergence of JF plus divergence of JD. As we know, the LHS, the left hand side term, what is the value, what will be the value of LHS here? The divergence of curl B will be equal to 0. So we will be having divergence of JF vector plus divergence of JD vector, it will be 0. So it will come out as divergence of JD plus is equals to minus divergence of JF. As we know, the continuity equation is divergence of JF plus del rho by del T is equals to 0, where rho is the charge density. It will give you divergence of JF is equals to minus del rho by del T. It will be equation number 19. If we compare equation number 18 and 19, what do we get? We get divergence of JD vector is equals to del rho by del T. If you go through the Maxwell's first equation, you know that Maxwell's first equation is, in the last step, what do we have? Divergence of D is equals to rho. What is D here? D is the displacement vector. What is D here? D is the displacement vector. So we get here JD vector is equals to del D by del T, where D is the displacement vector. So after the Maxwell's modification, equation number 13 becomes integration over the closed surface C. B dot dr, B vector dot dr is equals to mu integration over the closed surface as Jf plus Jd vector dot dA. This, we have put this value in equation number 13. So here what do we get? We get here we will put the value of JD. What do we get the value of JD? JD is equals to del D by del T. Del D by del T, where D is the displacement vector. This is the integral form of Maxwell's fourth equation after the modification suggested by Maxwell. So if we apply the Stokes curl theorem here, what is Stokes curl theorem here? It is integration over the closed surface C B dot dr is equals to integration over the closed surface S curl of B dot dA. So equation number 20 becomes integration over the closed surface S del cross B dot ds is equals to mu Jf plus del D by del T dot dA. Now it becomes Curl of B is equals to mu JF plus del D by del T. What is JF? It is the current density due to free charge, and D is the displacement vector. So curl of B becomes mu JF plus mu epsilon del E by del T, where D is the displacement vector, D is equals to epsilon E. Equation 21 is the differential form of Maxwell's fourth equation. Equation 21 is the differential form of Maxwell's fourth equation. As we know that Maxwell, there are four equations of Maxwell's. So whenever you prepare for the exams, you have to prepare all these four equations. So I should repeat all four equations. The first equation is based on Gauss law of electric field. The second equation is based on Gauss law for magnetic field. The third equation is based upon Faraday's law, and the fourth equation is based upon Ampere's law. So you have to learn all these four equations.